table partitioning. Yeah. So table partitioning. So the partitioning feature of the HANA database, what is the exactly the partitions will do? Partition means, so if you in your home, you will do the multiple partitions, right? So if maybe when you purchase the home, maybe you have the 150 square yards in that master bedroom, in that 200, so maybe in the 100, something like that, you will do the partitioning of your home. Same as like in the database also, we can split the column store tables horizontally into the subtables or subpartitions here. Disjunctive subpartitions here. In this way, the larger tables can be broken down into the smaller, so more manageable parts. So we can use this partitioning here. The partitioning is typically used in the multi-host systems or and also benefit for the single host systems also. It is very benefit here. So why? Because sometimes business tables has more than billions of records. In that case, searching the data from only in the table more than billion records, it will take longer time here. So it will take longer here. So then it will take the longer time period to searching it here. Instead of that, if you split this table entries into the multiple tables, so that searching from the smaller buckets, it's very simple instead of searching from the big top, right? So in this way, you need to split that records here. Here, the partitioning concept will help split the column store tables horizontally into subtables, smaller chunks. We can split it out here down into, we can break down into the smaller here or more manageable parts here. The partitioning is typically used maybe single host systems or multi-host systems. We can do that one using the HANA Studio, or we can also use the HANA cockpit to do the partitioning here. The partitioning is transparent, just it will use the SQL queries. So there is no additional skills are required, just only using the HANA Studio. So in the using the tabs, we can do the partitioning, and HANA cockpit, we can use it here. So we can create the table partitioning. We can repartition the already partitioned tables. We can repartition it. We can merge the partition to the one table. We can delete, we can add, we can move. So many things we can perform using the this partitioning here, right? So as per SAP, if any table has more than 2 billion records, more than 2 billion records, we have to split the table into the smaller chunks, right? So we have to do for the partitioning for the table here. As per SAP, the limit is 2 billion records. The limit is here 2 billion records here. So if the 2 billion records are crossed, then we have to go for the partitioning here. So when a table is partitioned, the split is done in such a way like each partition contains the different set of rows of the table. So there are the several alternatives available specifying the how the rows are assigned to the partition of the table. So like we have the types of partitionings are there. So depends upon the type of partitioning, the rows will be assigned to the partitions of the table. In a partition, the rows will be assigned here. There the multiple options are there here. So there are the advantages also here. By doing the partitioning, as we know, it's a there are the advantages. There are the many advantages are there here. So one is like a load balancing. Load balancing perspective, we have the advantages here. Advantages here. So load balancing. So load balancing means, so individual partitions across the multiple host, if you do it here, if any query partition is not processed by the single server, other server will process that request here, right? Simply, speedily you will get the data from the other partitions here, right? Other partitions you will get the speedily get the data here. And also the overcome the size limitations here, overcome the size limitations here. So there are the size limitations as I mentioned here. So a table should not cross more than 2 billion record, 2 billion rows, right? Cannot store more than 2 billion rows here. It's possible to overcome this limit by distributing the rows, additional records into the sub-partitioning, so that we can do that one here, right? So, and also the parallelism here, right? So, parallel processing here. Parallel processing means, suppose, so if any request to get the data, if any request to get the data here, what we can do, so here, if you are the table is partitioned into the multi-layer, then multiple layers, the operations will be several execution methods, the several threads will be, so do the pulling the data from the tables here, right? So that is the main advantages here, and also it will improve the performance, improve the performance of the delta merge operations and everything here, right? So so there are the many advantages are there by following the partition here. They are the they are the so types of partitions we have here. They are the types of partitioning here, right? So one is the so round hashtag hash partitioning hash. Second one is the so round robin. So robin here, round robin method. So the third one is called the here, that is called the range partitioning here. One is the round robin, hash, and range partitioning. Here, the three types of partitioning we have here. So, what is this partitioning means? Splitting the table entries. The rows are distributed to the so partitions according to the different criteria. The rows will be distributed here, right? HANA supports there the single level partitioning and multi-level partitioning also HANA supports here, right? Single level partitioning and multi-level partitioning also here. So one is the single level, and second one is the multi-level partitioning here, multi-level partitioning here. Again, for one partition, once again we have to do the partitioning here. So when it comes to the single level partitioning, so we have the types of partitioning, three types here. One is the hash, round robin, and range partitioning here. So when it comes to the hash partitioning here, hash partitioning is used to distribute the rows to the equally distribute the rows will be distributed equally to the partitions for the load balancing, and to overcome the 2 billion row limitations, it will do the partitioning here. The number of assigned partition is computed by the, so we have to provide it how many number of partitions we have to provide it, we have to give the value based upon that value, based upon the column ID. So then the hash partitioning so will be happen here. The rows will be shifting. You don't require in-depth knowledge of the hash partitioning here, right? Each hash partitioning, the column must be specified as the partitioning the column. Based upon that column ID, so the values will be distributed. The actual values of these columns are used here, right? So the main thing is so the primary key, the column ID, we have to so check it out here. Why? Hash partitioning. Hash partitioning means equally equally distribute the rows for the load balancing purpose. Suppose you have the 4,000 records are there in a table, then if you do the two partitioning, then partition number two, then 2k 2000, one partition 2000 entries, another partition 2000 entries will be, so another partition 2000 entries will be there here. So that is the main thing of the hash partitioning here, right? So that is if the table 4,000 records are there, that table split into the two tables. One is the so 2000, second one is the 2000 here, right? The next one is the round robin mechanism here. Round robin mechanism is like a, so that is also equally distribution of the rows to the partitions. But unlike hash partitioning, we don't, unlike like in hash partitioning, we have to define the column ID, column, those things we have to define it here. Here, you don't need to specify the columns here. The round robin partitioning is like a new rows. Equally, the rows will be distributed, but new rows are assigned to the partition on the rotational basis. So the rotational basis, the that rows will be assigned here, right? But in the hash partitioning, so it will distribute the records to the two partitioning here. Here the rotational basis here, rotational basis. So and also the table must not have any primary keys in the round robin mechanism here, right? So the partitioning the columns, so the partition depending upon the scenario, so we can the data we can do the partitioning here, the partitioning we can do that one here. So that's why round robin partitions, so mainly for the rotational basis, we don't need to select specify the any partitioning the columns and everything here. So partitioning the columns and everything, we don't need to specify it here, right? So that is the main thing of this one here, right? So range partitioning here. Range partitioning means here, so the range partitioning creates dedicated partitions to the certain values. Range means value based partitioning here. This is a different concept. You would require the in-depth knowledge on the values that are used for the partitioning. You require the in-depth knowledge here, right? So the partitions, range partitioning, which means we can create a partition for the, so every calendar month, so that we can range partitioning scheme can be chosen to create the partition for the each and every calendar month here. This require the in-depth knowledge. That's required the values are used to the partition the columns and everything here, partitions here. So range partition usually takes range of values to determine the one partitioning. Suppose like 1 to 10 in one partitioning, 11 to 20, one partitioning, 21 to 30. So like that, we can distribute the values wise, we can distribute it here, right? So range partitioning similar to the hash partitioning only, but here we have to use the primary keys and columns also we have to use it. So, but here the values wise, we have to take the, so this partitioning here, right? And that is the main thing here. So, and also once the table is partitioned, again, you can do the partitioning of the more partitions. You can do that one here. Multi-level partitioning to overcome the limitation of the single level as partitioning, the range partitioning. If the table has primary keys, these columns must be, so these columns must be used for partitioning of the columns here. Possible to, so not a primary key. Okay. So for the single, multi, we can do that one here. Hash, as to range, range to range. And so which means first as to hash we can perform it. Then first partitioning is the hash, then we can go for the range. Then range to range, round robin range. So multi-layer, multiple layers, we can go for the partitioning of the tables and everything here. So here this we have to perform from the HANA Studio. Using the HANA Studio, maybe you can connect to the one of the tenant database. You can do the partitioning here. Suppose example, if I go with the one of the Linux box here, we can also use the any our HDB also. So here what we have to do, you have to go to the catalog, related schema, table. You need to go to the, select the table. Actually partitions we have to do, show for the show table distribution, show table distribution here. Shade table distribution. Suppose like if I go with the BKPF, there is a one big table, finance table. So in this table, let's see the how many entries are BKPF table is there here. In this table, if we select the table, it will provide the record count. 663,817 records are there here, right? See, 6,63,000 records are there here in this one. What I'm going to do, I'm going to do the partitioning here. So right click, then partition the table. Okay, then here you can see the hash partitioning. Or hash partitioning means based upon the number of partitioning. So now we don't have any partition the table here. Only in one partition, this one partition, we have all the records are there here. Now I am going to do the partition the table like two level partitioning I am doing here. Two level partitioning I am doing here, right? So then click on the next button. So see here for the hash partitioning, we need to select the so you need to select the so partition primary key column we have to select it here, then click on the finish. See the partitioning is happening here, the partitioning of the table is happening here, it's done. So which means it will create the two partitions now here. See, one and two, one and two. See here, rows are equally distributed here. Previously 6 lakhs are there, 3 lakhs, 3 lakhs. So like that it is displayed here. Like that, the partition, the records are set here. So if anything is required, directly it will go to the this one, then it will go directly, it will go to the two partitions, two threads. It will fetch the data here. And also we can also do the some other merge the partitions also here. Once the partition is done, we can also revert back to the previous status as so here. We can also take the previous status also, non-partitioned tables also we can move it here. See, again you move to the non-partitioned tables here, right? So that is the one thing here. So and also you can also suppose like you want to go for the range partitioning. Range partitioning is mainly for the values based. Range partitioning is mainly for the values, number of values. Yeah, select the range partitioning, go for the next. So here you need to select the range of values here. So you have to provide the range where value range here. Suppose like in the out of 100, 0 to 20, 25 is in the one partition, 26 to remaining will be in the another partition. So then remaining will be in the another partition. So like that number of partitions, so we can set it out here. Number of partitions we can distribute it here. So, but this partition is required the some in-depth knowledge. What values you need to move to the which partitions, like that you need require the some knowledge is required here. Some knowledge is required here. That's why you need to have the suppose like based upon this number. Okay. Suppose like first to the 100 records will be in the 101 partitioning, then the remaining records into the one partitioning, remaining will be in the one partitioning. Like that we can split the all the records into the, we can split the records here. That's possible here. Okay, that's purpose we will use the this partitionings here, right? So it's if you can go to the HANA Studio tables, right click and show the table distributions and everything. So show the table distribution, then list of tables will be displayed, and right click of the table in one of the table, then you can just click on the partition the table, then the table will be partitioned here. So the table will be partitioned here. This is called the
Real time, this is a real time. This is one time activity, or we are getting this kind of request day to day.
not the day to day, it's maybe yearly once. So maybe once or twice in a year, like that. So it's not like that some customers you don't need to specify it. If the record count based upon the record count is based upon the value, not the value or times. So it's a base, this value we have to perform based upon the records. If the table has more than 2 billion record count, then we have to go for the partitioning of the table. If the today you done the partitioning, then within tomorrow you got the again 2 billion records means again you have to do it for tomorrow as well. So it depends upon the record count.
What is the advantage of this table partitioning exactly?
Advantage.
Yeah.
Did you miss this advantages which I explained here? I explained these advantages. Maybe you missed that one.
Okay.
So advantage means, suppose like this is the one table. In the one table you have the, so many records are there. Many records means there are the 4,000 records are there here. There are the 4,000 records are there here. Example. So getting the data, so just you have initiated the query, the getting the data from the this 4,000 records, why? Because only one thread, one table, it will initiate the, so just slowly it will check the all the entries and it will fetch the data and it will give the results back to the users. So there is a some delay in the performance here. Suppose in the 4,000 records, I will split into the 2,000 plus 2,000. Like that, I split the tables here. Here 2K entries, here 2K entries here. Then whenever I initiated the query, then it will issue the two threads here. It will issue the three threads, and one thread it will check in this partition. Second thread it will check in this partition. So wherever you got the immediate response, then it will inform to the users here. Which means searching from smaller small containers, it's a very simple, right? Instead of searching from the big folders here. So that is the main advantage is the performance wise, parallel processing, size limitations, and load balancing purpose. We have the partitioning concept SAP introduced in the SAP.
Yeah. Okay.
Can you show me how to revert this table partition?
Yeah, we can also revert it. Yes. In case something wrong, you want to revert back means you can revert back non-partition tables. Here you will get the how many partitions are there and all those things you will get it out here. Any table, you can select it, then you can go for the partitioning here. So here you can see the record count 20. If you do the partitioning here, suppose like I will do the partitioning the two layers actually. 220 only, right? Fine. So based upon the mandate, it is done 20 records only, right? It's simply navigated here. So two records, one and two partitions, it's record navigated. See, it's distributed. So 8 and 12 wise it got distributed here. Okay. So then if you don't
It's not
require, then
evenly distributing. It's not evenly distributing 10.
that system will take care of that part actually. But the system will take care of based upon the like size, multiple categorization system will take care of. So one user has some amount of 116 KB, another user has like 120 KB. So based upon that limitations, it will distribute the loads.
But in the range partitioning, we are getting that feature to define, right?
Range part, that's why. So range partitioning, you will get the range to range. Yeah, you will get the values. So based on that, you can go with this one. That depends, but most of the customers will most of the people will use the hash partitioning only. It's a very good one, and you don't require in-depth knowledge just to open the hash partitioning. Specify the how many number of partitions you required. Your rows will be distributed, equally distributed based upon the size or based upon the different criteria. It will be distributed here.
Before partitioning, you have selected that MANDT mandate. What is that?
That is the column, primary keys, column IDs you have to select. As partitioning, we have to select the column ID. It's based upon the column ID. So whatever the column ID you select it, your search query will go based upon that column only. It will select it here.
Okay.
Whether lakhs of entries are there, the lakhs of entries are there. If you execute the query, suppose like select star from one of the table name. Okay. So where, so here we have to use the columns where, so where username equals to, so Ravi. If I use this where condition, this is the column ID. In this column, based upon this column ID, so the records will be fetched out here. That respect to data will be fetched out. That's why. So we have to define the column here. Suppose like this is the table. In this table, which is the mandate? Mandate means client number, or B name means username. Based upon the username, the data will be displayed here.
Okay.
The data will be displayed here.
Yeah, maybe Ravi, I have a question. Like after distribution, like for example, 20 records will be splitted into 10, 10 or something. So next time the data insertions will be happening.
Both the
it going?
partitions. Both the partitions equally it will be distributed to the both the partitions here.
Oh, okay. Okay.
So some records are here, some records are here, some records are here, some records are here, some records are
So
here.
it's a kind of auto load balancing, like system will
yeah.
take.
Yes. That's why people will always prefer the hash partitioning only. So if we go for the range partitioning value based, so based upon the values, the particular values, based upon the particular values, the data will go to the only that partitioning only. So you have defined the partitions like in a table you have defined the partition. This is the first floor, this is the second floor. Suppose like 3 partitions you have defined. In this partition you have defined like 1 2 1 2, so some values 1 to 99 here. So then 99 to 100 to, then remaining, so 999 here, then 1002, then 999 here. Sorry, double line here. So what will happen if any data is coming? So that data is based upon the value, right? So then the value within the range, within this range, then it will go to the this partitioning. If it's within the range, this will go to the this partitioning. Then within the range, this partitioning. Based upon the values based, the data will be insertion will happen to the respective partitions here. Here you require the some in-depth knowledge, right? So what values we have to provide it, and how the entries will be. So maybe based upon the functional team inputs. So because they are the main for the data validations and everything, based on that inputs, we can go with this partitioning. So otherwise, some people years wise, 2003 to 2017 in one partitioning. So the values will be in the one partitioning. Then 2017 to 2022 in the one partitioning. Like that years wise, they can distribute the records as well here.
Okay. One more question, Ravi, on that scale out systems. Usually for the BW kind of systems, probably people will distribute the tables into multiple nodes. Do we have that option here in the HANA Studio?
Yeah, that time. So yeah, multi-host concept. Yes, we can distribute it. So multi-host concept. So the multi-host concept is there. So when you are using the multi-host range, so value range around that, yes, that's possible actually. Multi-host, the multi-host will be displayed in each host partition. In one this host, how many partitions, how many records are there, in each host how many records are there, so that here we can see it, and so that equally it will distribute it. Actually this main partitioning concept came from the BW systems only. Main scale out systems partitioning means mainly for the BW systems only. Why? Because there is a lot of analytical data, use data here for that one. So this will be helpful for the mainly for the BW systems only. Partitioning the multi-host systems here. Main benefit is partitioning is typically used in the multi-host systems only. That may be beneficial also for single host systems. Mainly SAP introduced concept for the multi-host systems like BW scale out scenarios only.
Okay, fine. Thank you.